In this video, we are going to talk about matrices. What are matrices? A matrix is an ordered array of numbers or functions. So for example, let's consider A, which is equal to, usually matrices are represented with this curly brackets. So matrix A equals 1, 2, 1, then minus 2, 7, 4, and then 6, 0, 3. So this ordered arrangement of numbers is a matrix. Another example is we could also have a matrix in this form: exponent minus x, exponent x, exponent x, and exponent minus x. So this is a matrix which is an arrangement of ordered functions. So matrix can also be represented in this form. Now, let's talk about order of a matrix. Order of a matrix gives the number of rows and columns of the matrix. So we normally represent an order of matrix in the form m by n, where m is the number of rows and n is the number of columns. So if we consider this matrix, matrix A, you can see that this has 1, 2, 3 rows. And how many columns? 1, 2, 3 columns. So the order of matrix A is 3 by 3. Now let's come to this matrix B. So this has 1, 2 rows, 2 by, and then how many columns? 1, 2 by 2 matrix. Now anytime m is equal to n for the order of a matrix, we call that matrix a square matrix. So a square matrix is a matrix that has the number of rows equals to the number of columns. So let's consider this matrix, matrix A equals 3, 2, 0, 1, 1, 2. What is the order of this matrix? So you can see that this has 1, 2 rows, and then the column is 1, 2, 3 columns. So the order of this matrix is a 2 by 3 matrix. Let's also consider this other matrix, matrix B, which is giving us 4, minus 2, 3, 0. So the order of this matrix, you see that there's 2 rows and then there's 2 columns. So this is also a 2 by 2 matrix. So what is the order of this matrix given by B equals into bracket 1, 4, 6. So you can see that the number of rows of this column is of this matrix is 1, and then the number of columns is 3. So this is a 1 by 3 matrix. And then let's consider B equals 3, 0, 1. So the number of rows of this matrix is 3, and then the number of columns is 1. So this is a 3 by 1 matrix. Now let's identify the specific terms in a matrix. If you have a matrix, let's say A equals an arrangement of small a1, a11, a12, a13, and then a21, a22, and then a23. So the specific terms in this matrix, for example, if we say we are looking for the term A13, you see that this is A13. So the row first, then before the column. So let's consider this matrix. Let's say matrix A equals 1, 0, 1, and then 4, 1, minus 1, and then 3, 6, 4. So let's find the term A12. So A12 means the first row and then the second column. So this is the first row and then the second column is 0. So this is A12. So A12 is equal to 0. Now let's find A33. So the third row 1, 2, 3, and then the third column 1, 2, 3. So A33 is equal to 4. This one. And then let's also try A23. So that means that the second row, which is this, and then the third column. So A23 is minus 1. So let's consider this matrix, which is matrix B equals 1 minus 1 and then 4. Then we also have 5, 3 and 0. And then 0, 7 minus 2. And then 1, 7, 6. So now, what is B42? So it means that the element that is in the fourth row and then the second column. So 1, 2, 3, 4. So this is the fourth row. 1, 2, 3, 4. Fourth row and then second column. That's this. So B42 is 7. Then let's find B32. So that's third row, second column. So 1, 2, 3. Then 1, 2. So third row, second column is also 7. What about B13? So B13. That means that the first row and then the third column. So this is the first row and then the third column is this. So we are talking about B13 is equal to 4. So now let's talk about some type of matrices. The first one we'll talk about is a row matrix. What is a row matrix? A row matrix is a matrix that has only one row. So for example, if we have A equals 2, 3, 4, 7. This is a row matrix. It only has one row, irrespective of the number of columns. Now, this is the direct opposite of a column matrix. So whilst a row matrix is a matrix with a single row, a column matrix is a matrix with a single column. So B equals, for example, if we have 0, 0, 1, this is an example of a column matrix. It only has one column, irrespective of the number of rows. Now, the next one we'll talk about is a square matrix. What is a square matrix? A square matrix is a matrix that has the same number of rows and the same number of columns. So, for example, if we have matrix A equals 0, 1, 1, 0. This is a clear example of a square matrix. How many number of rows? There are 2 rows and then there are 2 columns. So this is a square matrix. Zero matrix or a null matrix. So zero matrix. What is a zero matrix? A matrix is a zero matrix if all the entries in the matrix is 0. So let's say matrix A equals 0, 0, 0, 0. So this is a zero matrix or a null matrix. Now let's talk about the last one, which is the equal matrix. What is an equal matrix? An equal matrix is a matrix that has the same first. It has the same order. And then the second part is that the number of the corresponding entries are also equal. So the corresponding entries. So let's take an example of equal matrix. So if we have 2 matrices, let's say matrix A equals 0, 2, 0, 2. And we have matrix B, which is also equal to 0, 2, 0, 2. Matrix A is equal to matrix B because matrix A first, the order is 2 by 2. And then matrix B, the order is also 2 by 2. And then you see that the corresponding entries are also equal. So this is an equal matrix. Now, determine whether the following matrix is an equal matrix. Let's assume we have 3, 2, 5, 7, 6, 8. That's matrix A. And we have matrix B equals 3, 2, 5, 7, 6, 8, 7, 9. So this is matrix B. Now, is matrix A and B equal? You can see that matrix A and B has corresponding entries. However, matrix A is not equal to matrix B. The reason is because matrix A has order. So 3 rows, 2 columns. So this is a 3 by 2 matrix. And then matrix B is 1, 2, 3, 4. 4 rows, 2 columns, and this is a 4x2 matrix. So since they don't have the same order, then irrespective of their corresponding entries, matrix A is not equal to matrix B. So now let's talk about addition and subtraction of matrices. So let's assume we have matrix A equals 1, 0, minus 1 and 3. And then let's assume we also have matrix B equals 2, 3, 4, minus 6. What is A plus B? So now to add these two matrices, what we need to do is to add the corresponding terms. So A plus B is equal to, now 1 plus 2. And then this term is 0, so 0 plus 3. Then here is minus 1 plus 4. And then here is 3 plus minus 6. Bracket close. So A plus B is equal to 1 plus 2 is 3. 0 plus 3 is 3. Minus 1 plus 4 is 3. 3 minus 6 is minus 3. And therefore, this is A plus B. Now let's assume we also have matrix A equals 2, 4, 3, 2. And let's assume we have matrix B equals 1, 3, minus 2, 5. What is A plus B? A plus B is, so we add the corresponding terms, 2 plus 1 for this term. And then this term is 4 and 3, so 4 plus 3. And then this term is 2 plus minus 2. And then this term is 2 plus 5. So this is equal to 2 plus 1 is 3. 4 plus 3 is 7. 3 plus minus 2 is the same as 3 minus 2, which is 1. And 2 plus 5 is 7. So this is A plus B. So let's find A minus B using these same matrices. So just as we did for the addition and addition, we need to do the same thing for the subtraction by subtracting the corresponding. So here becomes 1 minus 2, and this side becomes 0 minus 3, and then this one becomes minus 1 minus 4, and then here becomes 3 minus 6. So this is equal to 1 minus 2 is minus 1, 0 minus 3 is minus 3, minus 1 minus 4 is minus 5, then 3 minus 6 is 9. That's 3 plus 6, which is 9. Now let's find 2A minus B. So what it means is that we need to multiply matrix A by 2. So 2A minus B is equal to, so if we multiply 2 by 1, it is 2. 2 times 0 is 0. And then 2 times minus 1 is minus 2. 2 times 3 is 6. So this is 2A. Then we subtract it from B. B is 2, 3, 4, minus 6. So if we simplify further, this becomes 2 minus 2. Then 0 minus 3. Then minus 2 minus 4. Then 6 minus 6. So this is equal to 2 minus 2 is 0. 0 minus 3 is minus 3. Minus 2 minus 4 is minus 6. 6 minus 6 is the same as 6 plus 6, which is 12. So this is 2A minus B. Now let's solve some problems. Simplify into bracket A squared plus B squared, then B squared plus C squared, then A squared plus C squared, then A squared plus B squared plus into another bracket 2A, 2BC. Sorry, here is 2AB, pardon me. Here is 2AB, 2BC, 2AC, then 2AB. So now this is equal to, let's put a big bracket here. So if we are adding them, we need to add the corresponding. So here becomes A squared, then plus B squared. But before we write the B squared, I want to put 2AB. So A squared plus 2AB, then plus B squared. Then for this side, it becomes B squared plus 2BC, then plus C squared. Let's put a bracket here. So bracket close. Then here becomes a squared, then minus 2ac, then plus c squared. Then this one becomes a squared minus 2ab plus b squared. So this is equal to, now you can see that this is the same as a plus b all squared. See, a plus b all squared is the same as a squared plus 2ab plus b squared using binomial expansion. So all of this can be synthesized to a plus b all squared. Then it's the same thing here. Here is b and c, so this one becomes b plus c all squared. So let me bring a certain bracket here. Now look at this. This is a squared, this is c squared, this is minus 2ac. This is the same as a minus c all squared. This is equal to a squared, then minus 2ac plus c squared. So all of this can be written as a minus c all squared. Then all of this one can be written as a minus b all squared. So this is the final answer. So we have this question here, which is evaluate into bracket cos squared x sin squared x sin squared x cos squared x plus into bracket sin squared x cos squared x cos squared x sin squared x. So just as we did in the previous example, this is equal to cos squared x plus sin squared x. Then this one becomes cos squared x plus sin squared x. Then this side also becomes cos squared x sin squared x. So here becomes cos squared x plus sin squared x. Then here also becomes cos squared x plus sin squared x. So but from trig we know that cos squared x plus sin squared x is equal to 1. So all of this reduced to 1 1 1 1. So this is the answer for that question. So simplify cos theta into bracket cos theta sin theta minus sin theta cos theta plus sin theta into bracket sin theta minus cos theta sin theta. So first let's expand this. So this side becomes, so this is equal to cos theta times cos theta is cos squared theta. Then cos theta sin theta is cos theta sin theta. Then cos theta times minus sin theta becomes minus cos theta sin theta. Then cos theta times cos theta is cos squared theta. Then plus sin theta times sin theta is sin squared theta. Then sin theta times minus cos theta is minus cos theta sin theta. And then sin theta times cos theta is cos theta sin theta. Then sin theta times sin theta is sin squared theta. Bracket close. So this is equal to, let's bring a big bracket here. So let's add this corresponding cos squared theta plus sin squared theta. Then here becomes cos theta sin theta minus cos theta sin theta. Let's bring a bracket close here. Then this becomes minus cos theta sin theta. Then this one plus cos theta sin theta. Then here it becomes cos squared theta plus sin squared theta. So you can see that here it goes to 0 and then this part too goes to 0. So this is equal to, however, we know that cos squared theta plus sin squared theta is 1. So here is 1, 1, sorry, let me cancel this. So this is 1, 0, 0, 1. If x plus y is equal to, into bracket 7, 0, 2, 5, and x minus y is equal to, into bracket 3, 0, 0, 3, then find x and y. So we have x plus y equals 7, 0, 2, 5. Then x minus y is equal to 3, 0, 0, 3. So what can we do? You can see that we can say this is equation 1 and this is equation 2. So let's add equation 1 and equation 2. Why? because here is plus y minus y will go to 0. X plus x is 2x, so we now have 2x equals, in one bracket, 7025, then plus, in another bracket, 3003. So 2x is equal to, now let's add this. We need to add the correspondence. So it becomes 7 plus 3, 0 plus 0, 2 plus 0, then 5 plus 3. So 2x is equal to, into bracket, 7 plus 3 is 10. And then 0 plus 0 is 0, 2 plus 0 is 2, 5 plus 3 is 8. So if we divide through by 2, so x is equal to half of 10, 0, 2, 8. So x is equal to, now 10 divided by 2 is 5, 0 divided by 2 is 0, 2 divided by 2 is 1, and then 8 divided by 2 is 4. So this is the value of x. So having found the value of x, what we can do is to write one of the equations and find the values of y. But we know that from this equation, y is equal to bracket 7025 minus x. But we know that x is 5014. So this is equal to 7 minus 5, then 0 minus 0, then 2 minus 1, then 5 minus 4. So this is equal to 7 minus 5 is 2, 0 minus 0 is 0, 2 minus 1 is 1, and 5 minus 4 is 1. So it's 2011. Find x if y is equal to 3214, and then 2x plus y is equal to 10 minus 32. So we have 2x plus y is equal to 10 minus 32. So let's make x the subject. Remember, we are finding x, but we know y. So in other words, 2x plus 3214 is equal to 10 minus 32. So 2x is equal to, let's bring this to the other side. So it becomes 10 minus 32, then minus to bracket 3214. So 2x is equal to, let's open bracket. So this becomes 1 minus 3, 0 minus 2. Let's close bracket. Then minus 3 minus 1, and then 2 minus 4. So 2x is equal to, now 1 minus 3 is minus 2, 0 minus 2 is minus 2, and then minus 1, minus 3 minus 1 is minus 4, 2 minus 4 is minus 2. So x is equal to half of minus 2 minus 2 minus 4 minus 2. So x is equal to 2 divided by, minus 2 divided by 2 is minus 1. Yes, minus 1. Minus 4 divided by 2 is minus 2, then minus 1.